So we are going to basically learn how to take the integral of a natural log. We're going to integrate the trig functions. So we know the integral of sine, which is what, Dennis? Did you use the golf thing?
What?
Did you use the golf thing just then? No. Okay. How many people are using the golf thing?
Yeah.
I know it's golf, but it works. And then the integral of cosine would be,
Wait, no, sine. Wait,
Yeah,
what?
if you
the
use
integral of cosine is,
Wait, no, wait.
No, the golf is
No, the golf
With
with
the
the
I
I
goes
goes
over.
over.
The I flies over.
Goes so
Right.
fast that it turns
so,
into
right, so, hold on, let's back up. Time out. Dennis,
Yeah.
what's the integral of sine?
Negative cosine?
Perfect. Dennis, what's the integral of cosine?
Sine.
Perfect. All right, good.
Alright.
Good. We're all on the same page then. What we haven't talked about is tangent, cotangent, cosecant, and secant. We'll show you how to do those, and they're not very pretty. And then you should all be able to balance a checkbook. You even know what a checkbook is?
No.
Yes.
Do you know how check works? Has anybody ever written a check?
No.
Yeah, I signed it.
We did a
You signed one.
In the
We
back.
did a practice for the
back.
personal finance.
Yeah. So remember that 20-minute discussion we had yesterday involving absolute value of u, and we had to talk about, well, if the absolute value of u, if u is positive, what's the absolute value of u, and if u is blah, 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 blah. That comes into play now. When we did this the other day, I did it without the absolute value because it was the easiest way to approach it. Now all of a sudden it appears, and why does it appear? You'll see in a second, because it becomes relevant when we take the integral of these functions. It's pretty simple because we're just going to go backwards. If the derivative of the natural log of the absolute value of x is 1 over x, what's the integral of 1 over x? I'm sorry?
1 over x squared.
Nope.
X over x.
If the derivative of the natural log of x is 1 over x, what's the integral of 1 over x? Natural log of the absolute value of x. They're reverse functions, or inverse functions, if you will. Those absolute value bars become very important. And again, we're not going to use this one that much. We're probably going to use the u stuff because they're not going to give you something as simple as that. They're going to give you another function. And you might be saying to yourself, self, wait a second, this is different. This is 1 over u, it's not u prime over u. Well, guess what? We're going to be doing u to u's with that in order to bring that u prime into there. Sometimes, and in fact, all the time, you need the absolute value bars there. But sometimes you'll be able to get rid of them. So the question is, when do I get rid of them? You never have to get rid of them. But if you're feeling all fancies in your pantsies, there will be some instances when you can make those go away. Okay, you ready? We'll start easy.
When you say U to U, you like actually mean like the U to U problems that we did like.
Yes. You got it.
So how do you do this?
These problems present themselves as a challenge for me because I have to grade them. And there are probably at least 2, maybe 3 or 4 different answers that are all valid for this problem. Yes? Bring the 2 out in front so you don't have to worry about it. What's the integral of 1 over x dx? Completely acceptable answer, version number 1. What else could I do though? Case, what do you think?
What, could you do, ln,
I'm sorry, the what?
natural log?
Yeah, that's what I thought you said.
Absolute value of, x over two plus c? No?
Not x over 2. Sam?
You said u equal to x to the negative 1.
No. Solving the problem is the same, but you can rewrite this answer in a different form.
X squared.
X squared.
X squared, right. Or the absolute value of x squared. Is it the absolute value of x squared, or is it absolute value, wait, I'm saying it wrong. Is it the absolute value of x squared, or is it the absolute value of x squared?
X squared.
It's the same either way.
Is it?
First, if you square either a negative or a positive number, it becomes.
Does it matter?
No.
No, so in this case, you can get rid of the absolute value. You don't have to, but you could. So here's the weird thing about it. If you get rid of the absolute value and you're not supposed to, it's wrong. If you have the absolute value there, you could have gotten rid of it and you didn't, it's okay. So I would argue, don't get rid of the absolute value. Question, Kevin?
So are both of those answers acceptable?
Both of these answers are acceptable, yes. And in fact, the third answer would be, you could have written it as the natural log of the absolute value of x squared plus c. You could have written it as the natural log of x squared, the absolute value, plus c. So I would argue that this is probably your best bet, or this for that matter. But if you start playing around with getting rid of the absolute value bars, number one, you don't have to do it, and number two, if you do it and you're not supposed to, you're gonna be in trouble. How can we make it more interesting?
Trig.
Anything else?
Any, yeah, just click on the screen.
Yeah, hit that.
Okay, there we go.
There we go.
Not Trig.
Sam, what's the first thing you notice about this problem? Anything come to mind? Other than the obvious, it looks like fun.
I don't know.
Okay. John, what do you notice?
The derivative of the denominator is the same as the numerator.
Ooh, which smells like what?
U to U.
You bet. So what do you want to use for you?
The denominator.
You're just shaking your head. What's the matter? You don't like UDU, or you just,
I really don't
is
like
this a coping mechanism for you?
You're shaking my head at every single thing.
I'm sorry, what? What did you say?
X to the fourth plus 3x.
I made kind of a big jump there because you hopefully can follow that. Do I need you to show you how I got to there?
Yes.
Oh boy.
Well,
Wait, I might actually have it on the screen. Hold on. Yeah, there it is. Okay, I did do it. So this is equal to the numerator. That cancels. So you get 1 over u. That's that. The integral of 1 over u is the natural log of the absolute value of u. Last step, put it back in. Can I get rid of the absolute value bars here? We're not going to, but can I if I want to? No. Cam?
Because it's not, everything's not even. The powers aren't even.
What does that mean?
That you could have negative numbers.
Correct. So just leave it there. And this is an example of what I talked about. This is a UDU problem. The only difference between what we did in the past and what we're doing now is that we've incorporated the natural log into these UDU problems.
So if it was like x squared plus 3, then you could get rid of them?
Yes. If you are focused on wanting to get rid of the absolute value, what you want to ask yourself is this number always going to be positive? If the answer is yes, then absolute value bars can go away. If it's not, or you're not sure, leave them there. Kevin?
Why do we have to take the derivative of u?
Because that's how you do a UDU problem.
Oh, I thought we were done.
We are done. this was to get to here.
Oh,
Yeah, okay? Yeah.
I just, so shouldn't you get like the integral of 1 over x to the 4th plus 3x du then?
No, you get 1 over the integral of x to the 4th plus 3x dx, and then remember we do with the one skip I did step. The one step I did. The one skip I did. The one step I did skip was solving for dx to sub it in.
And you also like subbed in u for the denominator. Okay, I get it.
Cameron?
So when you went from the integral of the first one to 1 over u du, do you have to do that?
Yeah.
Is that just for if
Yeah,
you're
because you have to
using
set
that-
up an integral in terms of u before you start doing all the calculus involved in taking that integral. Any other questions on this guy? What do you got?
How do you get like the 1 over u du? Like,
Yeah,
I'm confused.
I need the visual.
John, you want to handle this? Or did you have another question?
No.
You were answering his question.
Yeah.
Go.
Okay.
You want a pen? You want
Yeah.
Go, John, go, John.
Alright.
Go, John.
Let's see it.
You got
What color would you like?
Green.
Green it is. It's a little hard to see, but that's okay. We all have good eyes.
Okay, so so
Do you want me to get rid of that stuff so you can start over? Would that be easier?
this is fine.
All right, good.
Okay. So that's gonna be equal to u. And then we're going to do this, which is du over that, and that cancel out.
Wait, just to clarify, in that step you just wrote, set that equal to what? Beautiful.
And proceed.
Yes or no? I guess you should, I guess we should talk about bud and grassy people. Did you guys do UDUs the same way? Did you solve for dx? Or did you use a different approach? Or am I speaking a foreign language right now? I feel like Charlie Brown's teacher. Wah, 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 wah.
And this is just in
But
like
we
a weird
understand.
order.
What's that?
This is like in a weird order.
Yeah, probably should have played the page.
Confused again.
Just think about like a substitution.
Whoops.
problem.
Wait, actually.
It's like a little long.
You're substituting all the variables for new ones. Not variables.
I know you said it. I know you said you.
Pretend that's not there.
Yeah, that's yeah, because that's like the answer.
Okay.
Maybe that'll help.
We good with this?
Yes.
Okay, take the derivative of both sides. John, I'm repeating your work. I'm sorry. Solve for dx. Grassyites and buddites, are you with me so far? Yeah, so you did the same thing? Okay, good. Then we do a substitution. This becomes u on the bottom because of that. And then that I'm just going to leave there. And then dx is equal to that mess. Whoopsh, whoopsh.
Good sound effect.
I'm liking it a lot better.
Wait. No, I get it.
Show me answer
No, I got it.
That's why I'm not a teacher.
So you.
Then
Bingo.
Where does the 1 come
U's on the bottom.
It could just be du over u, right?
could be d over u, yeah, but I don't normally write it that way. So we just needed a review of UDU problems.
Yeah.
That has nothing to do with natural logs. Okay, all right. As long as the natural log business is, but you were solid then with the next step, right? Because you know now that the integral does.
That's new school, so because a couple more
Oh, I'm
days
erasing.
of that.
With it or until we know it?
Couple more days.
You are here
Do we know it for a couple more days or we need a couple more days till we know it?
No, I'm not here for
I'm exhausted.
I feel like that's what in the brain, in a couple days it went out.
kind of space in the brain.
No. I'll tell you right.
Just because I think it's fair that you be exposed to just about any type of problem that could be thrown at you, you should see a problem like this.
Thanks for staying.
You're not gonna do it now. You're not gonna do it now.
This presents a problem. So you're thinking to yourself, well, I've got a rational function. Every time we've taken the integral of a rational function, and almost every time it's been a u du. So let's choose the denominator to be u. Well, the problem is the derivative of the denominator doesn't cancel with the numerator. Okay, maybe I made a mistake. Let's make the numerator a du. Well, then the derivative of the numerator doesn't equal or won't cancel with the denominator, so pretty much I'm screwed.
You just gotta add that in.
So we're going to use a technique called split the fraction. We're going to turn that one integral into two different integrals. And again, this is hard to recognize. Let's just do it.
Do you add the
Let's
area?
not.
Well, you don't have to. I'm just trying to help you out. I'm going to split this into the following integrals. Take these two puppies and put them together. And write it as x squared plus 1, well that's a 1, over x squared plus 1 dx plus the integral of x over x squared plus 1 dx. I just wrote it in a different order.
That just
Wait,
looks like fuzzy
so
math.
is there
Why can you
any-
do that?
What is that?
Yeah, no. Because of adding.
Sorry, I went a little spastic there. There we go.
It'd be helpful to
I
show them both
guess.
the same integral.
How would you?
Thanks.
Is there any, my brain. Is there any way to be able to recognize that you need to do this? Just like that standing out.
The indication that you would want to try this would be that nothing else works.
So you have to try.
So
both of
before
these.
you cry, you would want to try splitting the fractions and see if it
Better
works. And usually the indication would be if you've got stuff in the denominator that you also see in the numerator, but there's other gunk up there, that'll be a good indication you probably want to split the fraction. Now, with that just sitting up there, do you see why I did that? What's the left integral going to be? I'm going to take the integral of 1, right? Okay, good. What about the right integral? It's a u du, right? So now the degree of the numerator is 1 less than the degree of the denominator. In other words, the derivative of the degree of the denominator is equal to that. Okay, so let's continue. This is 1, and the integral of 1 is x plus. Here I need to do a u du. What should u be?
X squared plus 1.
So this will become 1/2 times the integral of 1 over u du. What's the integral of 1 over u du?
Why is the integral,
Go ahead.
why is the integral of 1x?
And you don't multiply by dx.
It's, is that the derivative?
Yeah, what's the derivative of x?
Just
1, so the integral of 1 would be x. Remember, the derivative of a constant, sorry, the integral of a constant is that constant times x.
Why don't you multiply?
Your question was, Pat, where did the 2 come from, or the 1/2 come from? From this 2. Yes?
Why when you take the derivative of 1, do you not have to multiply it by dx? Just because by doing the derivative.
I don't understand your question.
Because you multiplied the x over x squared plus 1 by dx, or the integral of that, but not the first integral.
I still don't get it.
So when you, like, right after the first step, when you substituted in, when you got dx equals du over 2x, and then you have the integral of x squared plus 1 over x squared plus 1 dx, do you not multiply the dx?
I don't ever multiply it by the dx.
Yeah.
Or
Yeah.
substitute it in?
What?
What?
No, no,
I mean,
no.
I hate to be a jag, but you guys are asking me basic integral questions that you should already know. You don't ever do anything with the dx. It's there to indicate what the variable is.
It's been a long break.
Yeah, obviously. Go ahead.
So this is, I think it's a natural log question or something, I don't know, but how do you go from 1 over u to just natural log of u?
That's what the theorem I
You
just
go
did at the
backwards.
beginning.
Is that like the u
that was-
prime over u? Oh, that one? Oh wait, no, you're actually completely right. Wait.
I'm using some stuff we
You
just
changed
talked
it.
about.
Yeah.
Yeah.
I just couldn't recognize it at first, it's okay.
If I was feeling a little crazy, I could take that 1/2 and write it as a square root, but I'm not going to. Do I need these absolute value bars? No, because this is always positive. So I could, if I wanted to, write it the following way. But I don't need to. Why only 1c? I took 2 integrals. Why 1c? Yeah.
Because c could be anything, so like, if you had 2 c's, it would be the same thing as.
So would it be wrong if I had done this by saying this is plus c sub 1 and this is plus c sub 2, and then at the end combine it into a c?
I mean,
What's c
no,
sub 1 plus c sub 2?
c.
C, right. So, yeah. Either one is correct. Is that you? Are you okay?
Yeah, sorry.
You want to get a drink? I mean, I don't care. You can sit there and pick up all day long. But
I'll try and be
you
quiet.
want Casey to scare you at some point in time?
I'll do it.
You don't have to be quiet. I just feel bad for you. Are they hurting?
No, it's fine.
Okay.
He's so excited.
I know. Nothing. I'm watching Casey to see what he's going to scare. Because when he scares him, he's also going to scare the rest of us.
That's what I wanted to do.
I'm so jumpy.
All right. Are we good here?
Yeah.
That's what we did. Da, 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 da.
Oh.
What is that problem asking you, before we even get into the nitty gritty, what's that problem asking you to do? Nope. Solve, thank you, Sam. Solve, good.
Wait a minute. The differential.
What's a differential equation? Grace?
Maybe it's just like what it before you differentiated it, what it equaled. Is
Yeah.
that what it is?
What am I asking for? Y, good. And if I have dy dx, how do I get y?
Integral.
Take the integral. I want to do that. Well, this will be fun. We've got a product with an quotient.
Log rules.
Some logs in there. Yeah. The only thing we're missing is trig. Wouldn't it be weird if Twig? No, so I developed a speech impediment. Wouldn't it be wonderful if Twig showed up by the end of this quote?
We just went signs all of a sudden appeared.
What's that?
Because you were talking about logs.
Twig.
Oh.
That's actually funny.
Yes.
So here's where we.
Well, I mean, we're
This lesson has 2 opportunities in here where you need to make a decision. Are you a memorizer, or are you a solver? And I'm not saying one is better than the other. In other words, I'm going to take you through this process, and you're going to get an answer that's kind of cute. So then you just have to decide, am I going to memorize the fact, because this pops up quite a bit, am I going to memorize the fact that the integral of 1 over x times the natural log of x is equal to blah, blah, blah? Or every time that pops up, am I going to go through this process? The same is true with the trig that we're going to do in a second for the other 4 trig problems. Are you just going to memorize what those trig values are, or are you going to go through the process every time? Question?
Yeah, when you say like you can either memorize or go through the process, if it's show your work on the AP, do we need to go through the process on
They're
these?
not going to ask you to do these derivations.
Cool.
Okay, so here's the work. This is what I would do. The natural log of x is a u to u problem because obviously there's no product rule or quotient rule in integrals. So you have three options. You can make, like it says up there, you can make u equal to x, you can make u equal to x times the natural log of x, or you can make u equal to the natural log of x. The correct answer is to make it equal to the natural log of x, and here's how it works. Okay. You choose u to be the natural log of x, therefore du is 1 over x, because the derivative of natural log of x is 1 over x. Solve for dx and you get this. Conveniently enough, x cancels with the bottom, and we get back to your old friend, Mr. Integral of 1 over u du. The integral of 1 over u is the natural log of the absolute value of u. You sub it back in and you get this cute little answer of the natural log of x.
Does that simplify?
Nope. Which again leads you to that. So what do you want to do? If that shows up, do you want to go through that u du problem, which is fine? Or do you just want to put that on a flashcard or a note card and remember it?
Add it to the flashcards. Add it to the flashcards.
There you go. That is probably flashcard worthy. And I think on the homework last night, you actually had a problem where you had to take the derivative of the natural log of a natural log of something, right?
Yeah.
I'm
Yeah,
sure
that's the
we'll end up
one I
talking about
stopped.
that in a couple minutes.
That's when I stopped.
Cash?
Is the natural log, can you still treat it like a product and say ln x to the ln? Or is that
No, because ln is not a number. You can't. You have to take the natural log of something.
yeah.
That would be like saying the sine of x raised to the sine power.
So just leave it like that.
It doesn't work. It's a function, not a value. Okay, heads ready to explode yet?
We already have.
Great. Then let's do some trig. Woohoo! We have 4 to cover. I'm going to derive one of them for you. Show you where it comes from. I'll give you the other 3. You do with it what you will. Giving you some options here. This is America. So let's talk about tangent. The reason we didn't do tangent, cotangent, secant, and cosecant until now is because we need the stuff we've just covered in order to find the integral of tangent. And we have an easy way to check. When we're done, we can take the derivative of it and we should end up back at the tangent. That's why we had weird things like secant tangent as integrals and tangent squared as integrals. Any guesses what I should try?
I mean, you could try to like make it into sine, cosine,
Love it.
and go.
Then what?
Oh, you're just being nice.
Yeah,
Then you could like do the u to u,
Uh-huh.
and do it. So you could do the derivative of sine or cosine. So you probably would do like the derivative of cosine. So I can't. I'm on the spot now.
No, it's perfect.
Yeah.
Right, so now I just stand here and click.
Yeah.
Write it as sine, cosine. Choose one of them to be u. You said you wanted to do which one?
Whatever like the derivative of the other is.
So you
it's
don't care?
cosine.
Cosine? Okay, what's the
Yes.
derivative of cosine?
Sine.
Sine, so that would probably work out
Sines
well.
would- Yeah, the signs would cancel.
Could you do sine also?
No, well, because then you get a negative, wouldn't you?
Does a negative, I mean, maybe our answer has a negative in it.
Oh,
does.
because of the
Yeah, the
absolute
derivative
values.
is
and stuff.
negative.
Okay. Work?
No, it didn't.
Oh!
I thought he was like, I got
You got me
the
though.
solution.
I think that was just a hiccup.
I thought he was really excited about negative integral of 1 over u. Okay, so did you say cosine or sine, Didi? I don't remember.
I think I said sine.
Okay, well, I did cosine
Okay, that's fine.
and got negative sine because then when you solve it cancels. So this cancels and it leaves you with a 1 over u, which is why we had to wait until now, because up until now, we didn't know how to take the integral of 1 over u. Now you know the integral of 1 over u, which is natural log of the absolute value of u. So you sub that all back in, and you get that as the integral of tangent. Question?
Oh, wait, never mind. I was thinking of it the other direction.
Glad I could help. Do you need the absolute value bars?
Yes.
Yeah, you do. They can't go anywhere.
Flashcards.
Dee Dee, back to you. Put you on the spot. How would you do the integral of cotangent then?
So it'd be secant over cosine over cosecant. No, the opposite. Cosine over sine.
Cosine over sine.
Yeah.
Exact same process.
Yeah.
Bangity bangity boom, you're done.
Sure.
Good.
Write that on the.
And then secant?
Secant is
1 over cosine.
Oh yeah.
So there they are. Question?
Since you know for like secant and cosecant that those are 1 over cosine, 1 over sine, can you just, when you do a derivative, can you just do 1 over that and take the natural log of it? Like 1 over cosine, take the natural log of it?
Wait 1 second. Because there's something I need to address that will, I think will answer your question.
Which ones did you just figure out?
Dennis, good job on the sine and cosine, by the way. We had it confirmed with the yellow box there. Good job. Okay, now a common mistake pops up now that we've done the integral of 1 over x, or 1 over u. And I'll give you another second to finish writing this down, then I'll show you an example of the mistake people make. You will still probably make this mistake, but at least I can say I warned you.
Love the confidence.
I have a ton of confidence. I'm confident you're gonna make this mistake.
Oh my god.
You know
Did
what?
you just get that
I
too?
think I'm gonna try to beat you on that one.
Challenge accepted. I hope you do.
Picked the wrong person to challenge you on messing up on tests.
Don't sell yourself short.
Take home test Friday? I know.
Take home test and study session at the library, guys. Come on.
I was promised one
Wait, is this next test going
Yeah,
to be a
Mr.
take-home
Reed.
test?
This is a
Not the
take-home
whole
test.
test, part of
We're
it.
all meeting at the library.
This is a quiz on Friday.
No, I'm saying the test.
Yeah, when we get to the part where we do the take-home test. Yeah, the whole test won't be take-home, part of it.
The majority.
The Bud Knights and Grassy-Heads don't know about the take-home test.
I'm sorry, was that English?
The Bud
You
Knights-
said it first.
The Bud Knights.
Oh, Bud Knights and Grassyites, I didn't, yeah. So I promised them they could have part of their test as a take-home test.
That's like where you write
Okay, so here's the common mistake that people, you, will make. So now that you've seen the integral of 1 over u being the natural log of the absolute value of u, everybody starts doing these problems the exact same way. And this problem, you will do the following.
Is this what we should do?
That's what I would've done.
Right. Doesn't work that way. Okay. And in fact, you can't do that. We don't know how to solve that integral. It doesn't work out. We have to use some different techniques, some of which you won't cover. So when you get to problems that involve 1 over, it's not just a matter of doing it that way because it has to be a UDU problem. That's not a UDU, it's not UDUable, if that's a word. So don't do that.
It's not.
You just
do
split
it.
it up.
Don't you need these to cancel for you to use?
Correct.
So like, obviously one is denominator, nothing's gonna cancel unless you somehow get one.
So John, I'm thinking by your question, you're asking me, can I split it up into 1 over x cubed plus 1 over 2 to the x?
Yes.
That doesn't work. Mathematically, that's not sound math.
Okay.
Because a over b plus c is not equal to a over b plus A over C. The only thing you can split is the numerators, not denominators.
Only if there's like 2A.
No, you can never split the denominator, only split numerators.
Should we maybe make the denominator write it as x times in parentheses x squared plus 2?
Still doesn't work.
Okay, I was thinking it was a step
No,
in the
you
direction.
can't solve that problem. So don't try. It'll make you sad. Okay. My point being, what's gonna happen is you're gonna see the integral of 1 over anything, and you're gonna think, well, that's just the natural log of the absolute value of that anything. And it doesn't work that way. It's gotta be done, unless it's just plain old 1 over x or 1 over u, it has to be done as a u du problem. And in fact, the goal of the u du problems is to reduce it to something like 1 over x or 1 over u. Okay?